Okay. Well, I think it's about time to go here. So welcome, everybody. Thank you for joining us here today. This is Meet the ISENs, the Industrial and Systems Engineering Department's annual fun introduction event. We do this as often as we can every year. And this is a great opportunity to get to know who are the faculty and researchers in industrial and systems engineering. What sorts of research are they doing? But also, this is, it's kind of two purposes. The one is we want the students to know who the faculty are as people, as well as the ones standing in front of the class and teaching you. And so we got a little bit of personality in this, and then we also talk about here are the professional and academic things that we're interested in. So without further ado, meet the ISENs. Thanks for being here. And there we go. So the purpose of this event, again, we're going to learn a little bit about who our industrial and systems engineering faculty and students and researchers are, what is a little bit about their professional and personal interests, and what are the opportunities for research. Let me introduce myself, please. My name is Thomas Ferris, Tom Ferris. I'm an associate professor in industrial and systems engineering. You're going to hear more about myself and my personal interests and research when it's my turn, but I am introducing this event because I'm one of the two track coordinators for the engineering honors organization that's at Texas A&M. So we are the ISEN track coordinators, myself and Abby Vintilla, who is one of our undergraduate advisors. And so she works closely with me and the honors students, but she's also, available for anybody who's not in the honors program for advisory needs. I also want to recognize and give and to give some props to our outstanding undergraduate advisor team, which of course includes Abby, but also Gina Goodson and Maritza Garza. And then we have Yesenia Zavala, who is our recruitment coordinator, helped me put this presentation together, and is also a member of undergraduate and advising group. Our leadership here, Dr. Nataimo is our new permanent department head. Very glad that he was able to send a video along. He has a family event. He couldn't be here for today, but he sent a nice video, so I put him in the agenda. Dr. Grawl, who is our undergraduate program coordinator and works very closely with our undergraduate advisors, as well as Abby and I for engineering honors related things. And then Dr. Garcia, who is our graduate program coordinator. And I know we're going to have undergrads and graduate students at this meeting. So even though it's going to have a little bit of a flair of, meet these faculty who you've never, had a chance to interact with yet and hear about their research, it is designed for all industrial and systems engineering students to hopefully get some benefit out of this event. So excuse me for going, back to the basics here a little bit, but some of you may be thinking I have no interest in doing research, which is fine. That doesn't mean anything wrong. You either like this aspect of academia or you don't. Perfectly fine. But what is research? Could you be a researcher? Well, it might be easier than you're imagining. To be a researcher basically means to address questions that don't have a clear answer yet. And there's a lot of those out there, obviously, in science. And so this is a set of methods. When we say you are conducting research, you are working with others who have been trained in these methods and learning them yourself to get ways to answer these sorts of questions. And research is about creating new science. So everything that's in your textbooks now has at one point in the past been discovered or developed by some other scientific group, and it became the thing that goes in the textbook. So what happens with the things that we haven't learned yet or we haven't put in the textbook? We need research to be able to identify those for us. Undergraduates in particular may not be thinking very much about research, but I'll give a quick story. Myself, when I was a second-year undergraduate engineering student, my first year in industrial engineering, I talked to a few faculty there, and I knew that some of them were working with undergrads in their labs, And I said, that's the kind of thing I'd really love to be a part of. Next thing I know, I worked for 2.5 years and loved it. I was working with mobile robotics projects, and it really kind of hooked me on the idea of research and in the pursuit of unknown questions. And then I went to grad school, and then I became a professor. So that's kind of my own path. And I've always looked back on that experience, that opportunity that the professors gave me to work with me as really formative kind of in my own life. And so it's pretty important to me to be able to support that in any way we can. And that's a really big deal, with the engineering honors program, as well as, our department in general, and an engineering X, that X factor that undergrads are going to be seeking as part of their degree. Research is a great way to have that X. And so we talk about a unique experience. If you're doing a class project, so is everybody in your class, but research gets to be your own project. You get to be the only one who knows as much as you do about that particular topic or that particular problem. Great thing to talk about on job interviews, for example. What did you do? Well, I got great grades. Oh, and let me tell you about this research experience I had, which is going to be unique and very interesting. Those of you who are interested in graduate school, and by the way, I am always happy to talk to anybody who maybe is considering graduate school without leaning on you too hard. I think graduate school is an excellent idea if it's for you. I can give an objective sort of pros and cons of that. By all means, reach out to me. I'd be very happy to talk about that possibility. And there's probably quite a bit that undergrads don't know about what it means to be a grad student. At least I know that I didn't know when I was an undergrad. And so I'd like to be able to share those with you so you have the information about what that means. But if you have experience as an undergrad, your graduate school prospects are way higher. And in fact, that is often the distinction between somebody who has a great GPA and somebody who has a great GPA, but also research experience. That's going to be the ones that are really the most coveted students for a program. And then professional flexibility as well, because you're going to be trained to be industrial and systems engineers. But a lot of you will have an opportunity through your research experience to learn new and unique skill sets. I mentioned I worked with mobile robotics. So then today I have a knowledge about how to program and work with robots, with robotics. And so that's a skill set I wouldn't have otherwise gained as, part of my normal classes. If you are interested in research, there are a couple of steps I would recommend, and know that in the engineering honors world, I like to be as much of a resource for students who are interested in research as I can be. So please come to me. I should have put my my email address up here. I'll have to do that when you see me give my own presentation. But by all means, I think this is a great thing for any undergraduate student to undertake, and I'll just talk a little bit about what that means. Engineering honors students probably know that they are required as part of the program to do at least 6 hours, credit hours of research, and we talk about that regularly. So, when you meet with me, that's a great thing to talk about. But again, it's not a limited thing to just engineering honors program. This is really open to any enthusiastic and interesting students, right? Oops. So the first thing you'll do is you want to find something you're interested in. So this is either through classes, through word of mouth, through a friend of yours who's doing research that you think is also really, really cool and would like to be involved in. And to go and talk to the faculty who are leading those groups, those research projects. The easiest thing for a faculty to agree to is to talk to an enthusiastic student at a time they've already set aside to talk to students. And so think about office hours. A really great thing is to just email a professor and say, I heard a little bit about your research, either through class or whatever. I'd love to talk a little more, see if there's something I might be able to help with. When are your office hours that I could come in and talk about that? And then I'm also available to help you connect with faculty as well. You don't have to know, exactly the project or exactly the person you want to go to. I can help with that. Step 2, typically you don't just say, hey, I want to be a researcher, and then boom, it's set up. You got to do some efforts, you know, to kind of ease into a project and be prepared to be a meaningful contributor. And this is usually in a volunteer capacity. So people start, especially with undergrads who are legitimately interested in research. It typically means, okay, well, here are our lab meeting times, or here are our project meeting times, and start coming to those and absorb a little bit and absorb a little bit more, and volunteer to take on part of the project and volunteer to help out with data collection or whatever. And then, you know, from there, we can start to talk about formal research agreements. And this is where we would register for credit hours. So there are, you can register for hours, so you get credit on your transcript for doing research. Roughly equivalent to a 3 credit hour research project is about 10 hours of work per week, you know, in meetings and outside. So it's very similar to a normal class load that way. And then you can work with myself or Abby or another undergraduate advisor to get those courses on Howdy, so you can sign up for them. So that's essentially how the research credit gets on the transcript. Is the advisors will set up a specific section with a specific professor, and you will then have a chance to register for that for however many hours you agree on. You must have the approval of the faculty, because they won't set up the section until the faculty approves it. And then you conduct the research, and you do this in whatever format best fits kind of the relationship you have with the project group, with the faculty. 6 credit hours as a requirement for engineering honors. I think most of you know this, but this can be broken up however is best suiting the project. And I usually recommend earlier is better, and you can kind of do 1 credit hour now, another credit hour next year, and then 2 or 3 when you've got, you know, more time to devote in a semester to this sort of work. And sometimes it makes sense based on the timeline of the project to do that sort of arrangement as well. Engineering honor students will also submit a written report of their research, either in the form of a thesis, an undergraduate research thesis, or in a peer-reviewed publication. And I am encouraging more and more the latter one here. A peer-reviewed publication means you're submitting to a scientific journal or a scientific conference that has a review process, and the faculty will know very clearly about which ones this counts for. But there will be other scientists who read your paper and decide if it's good enough to publish or not. So there's a slightly higher bar to cover in terms of the validity and the rigor of your science when that gets published. It also reaches a much larger audience when it is published to the public, and it has that stamp of other scientists have reviewed this and agree that it's good. So peer-reviewed publication is generally more valuable to the faculty and more valuable to the students who complete the work for about the same amount of effort as writing a full thesis. This is an example of an outstanding honors thesis. This is Tyler Weiner, one of our graduates from a few years ago, and Dr. McDonald, who you'll hear from in a moment, who was his advisor. And we're very proud of this moment here because Tyler here with his thesis, so this is the research he did as an undergrad engineering honors student with Dr. McDonald, using machine learning algorithms and driver performance data to detect and differentiate types of distraction. And this won the university-wide Best Science and Engineering Thesis. And so we had a big ceremony, and he got that recognition, which is a pretty big deal. So we're very proud of him, and that could be any of you as well. So I want to highlight that industrial and systems engineering has different sub-areas of focus. We all worked well together, but these kind of form the 4 pillars of scientific and research, scientific knowledge and research that's going on in our department. So, and we have representatives from each of these groups who will present today, faculty. First, our advanced manufacturing group. And so, industrial engineering is historically about production. about producing things. Industry is about product and service, and so this is the how do we produce things now? How do we fabricate things and create physical items? And now the world is very advanced, and so in terms of this, and so we have people at the cutting edge of these technologies. Yes, is someone?
Yes, this is Farzan.
Oh, hey.
Hey, I don't think we see your slides.
Oh my God.
I think you're talking about things we don't see.
You're exactly right. That's funny. What a start. Thank you, guys. That's why we got on early, to make sure we got that right. All right. So this one. Thank you very much.
Welcome.
Okay. That's funny. So now you can see the advanced manufacturing, I assume, right? Everyone?
Yes.
Okay, thanks. Thanks, Dr. S. All right, engineering data science. When you hear the phrase big data, and that being a nice challenge in a lot of different application fields, I know in healthcare, healthcare data are certainly in this realm, big data, and how do we make sense of these messy and incomplete sets of data so we can make good decisions with them. The science of doing that is also covered within our group here, within one of our focus areas, engineering data science group. Operations research, this is a class that industrial ISEN students will take in their third year, and there's a couple of them. This is about mathematical modeling, but it's more of the theoretical math side of solving complex problems in industrial and systems engineering. And you'll hear some from some of our faculty there. And then health and human systems engineering. This is my particular area, but having to do with how we design systems that involve humans. And so human factors is one of the terms you would hear spoken a lot in this group, human systems interaction and integration, and designing technologies, tools, processes to work with people who are very messy pieces of a system to get to work. And then finally, tying everything together, we are a systems engineering department. And rather than say, hey, here's a picture of systems engineering, to me, this whole slide represents what systems engineering can bring. And it's this recognition of the complexities of how things work together and being able to manage those complexities so that we can solve monster big problems. With that, we're about to start the presentations now. The way that this is designed to work is each faculty will get just a couple of minutes to introduce themselves, so they're going to be talking rapidly. We want the students to have a chance to chime in and say, oh, I have a question, or I have anything you want to say. So there's a couple of ways to do that. The first is, and this is the preferred way, enter your question in the chat for this, for this presentation. Yesenia will be watching the chat, and she can then ask those questions, verbally after each presenter. You're also welcome to raise your hand if you know how to do that, within the, I think that's also in the chat function. But then that will, you can ask your question verbally if you'd like, and we'll do just a minute or two after each presenter, even though they'll be rapidly speaking, we'll give a little bit of space for those questions. Also, almost every faculty here will have either listed their email address on their slides, or you can get that email address by talking to either, Yesenia, myself, or Abby. So you can take that. I also have then a sign-in QR code here. So engineering honors students, if you can snap your QR code on this, or here is you can type in that address. Actually, maybe. Okay, well, I'll put it in the chat window when I'm stopped talking here, so that you all can use that if you want. QR code for engineering honors students in particular, and then this will count for one of your required events. And I've also got this on our next slide here. I'm going to have this on our schedule slide, so this will just be up there. I'm sorry, here's the sign in for engineering honors. If anybody has any questions and they don't like the chat function or any of the other options, this is also a venue by which we can ask questions, but I think this one is going to be follow-up after the event, if you go to that one. Without further ado, I am very pleased to introduce our first speaker, of the Meet the ISENs event, and that is Dr. Tony McDonald. And so I'm going to stop sharing my screen, and I will turn it over to Dr. McDonald and Yesenia to get that up and going. Thanks a lot, everybody. And then I hope I put the right screen back up. Do we see our schedule?
Yes.
Okay, good. So thanks again, Dr. McDonald, and I'm sure he would love to have any email follows up, just goldenarches@tamu.edu. No, McDonald@tamu.edu. Thanks again, Dr. McDonald. Our next speaker is Dr. Moreno. Is Dr. Moreno on?
Yes.
Thank you so
right
much.
Time.
Good. Yeah, right.
I'm glad you're late because I was late. So that's
perfect.
Good.
Great. Well, then I will stop sharing. So nice to have you here. And I don't know if you were going to share your slides or if Yesenia has.
Oh, I thought you were going to have them, but I have them. So
we do have them.
You have them? Okay, yes. If
Yesenia
you can
has
put them,
ready to share.
that would be great.
I can share them.
Okay, awesome, Abby. Thanks.
Great.
I'm having technical difficulties. Sorry, everybody.
Well, me too.
Yeah, but at least your technical difficulties, Yesenia, didn't cost you your hair. Like, the boiler exploded for Tom Ferris, and that's what happens.
Fell right off. I was working so hard.
There we go.
Awesome. So, yeah, maybe you can, enable editing. Okay.
Sorry. I don't mind going a little slow too. Come up here.
Okay, awesome. Hi, everybody. So we have the deal is we have 10 minutes and then we get the music or something.
Yeah, you'll get the music if you want it. Well, you'll get it.
Okay.
Yeah,
So no, I think I can beat that. I'm Dr. Eric Moreno Centeno. I'm from Mexico, and in Mexico we use two last names, so that's why I hyphen them because I want to make clear that this is my whole last name, and I'm not Dr. Centeno. I don't know that person. So if you want Dr. Moreno, Dr. Moreno Centeno, that's fine, but or just Eric is fine, but yeah, never just Centeno. That drives me crazy. So I'm an associate professor. My main research is operations research, and the courses that I commonly teach is ISEN 320, the Operations Research 1 course, and the ISEN 489, optimization algorithms. That's I guess not as common, but yeah, every now and then I get the opportunity to teach that, and it's I teach it like a follow-up of the 321. And then my research is, my last two projects were in energy, optimizing the energy grid, how to make it more efficient. And the other thing is designing round-over-free optimization algorithms. So to solve the problems exactly, essentially, and to any desired level of precision that you want. And then my hobbies are, so actually my two students, I say my former projects because my two students recently graduate. And that's, you can see them here in the pictures, the first two pictures, you can see them here. Now, as you can see, they were, they are not very clear pictures because they were COVID fatalities, not the students, the pictures. So, the commencement was canceled and therefore I don't have their pictures with me holding them. So those are representing those two students, one in energy and one in numerical linear algebra, essentially. And then my hobbies, I like to play basketball, scuba diving. There you can see two photos of a whale shark with whom I scuba dive. Actually snorkeled for a little bit. So those are, amazing things. And that was in the Red Sea next to Saudi Arabia. So that was pretty cool. And I also like to mingle with the Agri Honors office. I'm a frequent flyer there. I have a lot of miles with them. So I can get to travel to a lot of fun places. And actually so much that now I'm part of the Honor Council. So which means I'm part of the investigators and the panelists and so on and so forth. Okay, so I'm also the ISC Student Chapter Advisor. No, sorry, I haven't finished with that slide.
Sorry.
Yeah, so there you can see at the top, that was maybe a couple of years ago with with the officers at that time. Again, with these officers, we haven't had time to take a nice picture, so it is what it is. And then this is with my wife, and then that's my wife with my 2 kids in the baptism of my little daughter there. They're now 5 and 7 years old. And this, and you know, Juan Pablo is the boy, he's super calm. And then Nina is like Hurricane Nina, essentially. I'm sure they will call a hurricane by her name, like I'm sure that will happen. So good, now I'm done with this one. Oh, and then you can see all my students, other students there at the bottom. Okay, so undergraduate research opportunities. Essentially for undergraduate, for undergraduate research, what I have is I'm seeking for persons that like math and programming-oriented students who excelled at my class and at ISEN 320. So that then, because what I am building with undergraduates is I'm building an intelligent tutoring system for the, you know, following students that they have. Essentially, it's a system that will create an infinite amount of examples because students always like examples. So this one will randomly generate problems for them and will actually solve them kind of step by step by hand. So we are developing that. We right now have like 4 types of problems that are fully automated generated that and fully generate solutions. And then the next thing is actually to make it intelligent. We need to interact with it so that you can input your answer and it gives you feedback and hints on what you can do to correct it. So that's the type of research I like to do with undergraduates. It's very applied, but you know, related to what I do. So if you're interested in that, the music is on. Is take my class. I'm giving 2 sections of this class next semester. So you cannot escape me if you're up for linear programming. And that could be a good thing or a bad thing. I don't know yet. You'll find out later, but we'll see. Okay, I'm done.
Lovely. Thank you so much, Dr. Moreno. Yes.
Okay, I apologize. I do need to leave. I'm in the middle of another thing, but I really wanted to be here with you guys. So it was great. Well, talking to you, not really meeting you, but you know what I mean. And you know, it's hopefully some of you get excited by this stuff. It's an awesome department, and we do awesome stuff. So just be part of it. You know, the more you are integrated in the department, the better. So please take that opportunity. Okay, good. Sorry about that, Nom.
Thank you so much, Dr. Moreno. Dr. Centeno, I mean.
Yeah, right.
Yeah, no, I really appreciate it. We all do. Thank you very much. You can follow up with Dr. Moreno via the email he left, emc@tamu.edu.
Right. So if you like physics, it's like the Einstein formula, just without the 2.
Oh, yeah. Yeah, that's nice.
Yeah. Actually, I also own EMC2 at tamu.edu. So I should probably use that. It's more cooler. My undergrad was in physics, by the way. So I actually have
very nice.
two ways to substantiate the use of that email.
Well, thanks again, and we will move along here to Dr. Eraguntla. I believe he is Dr. Eraguntla on, and I will stop sharing so we can get his slides up. Thank you very much for joining us, Dr. Eraguntla. So
yes, I'm here.
Do we have your slides or? Okay, very good. Here we go. Very nice. Thank you.
Good afternoon, everyone. Thanks, Ferris. My name is Madhav Eraguntla. I'm an associate professor of practice in the department. In terms of undergraduate courses, I teach ISEN 310, uncertainty modeling for industrial engineers. And I see that some of my students are here today in this session. And I teach ISEN 413, advanced data analytics for the industry. By the way, not only I'm teaching here at A&M, I'm a graduate of Texas A&M. I graduated 25 years back from the department. And the photo you see at the bottom right is 25 years back in the old Zachary building when I was a graduate student, much younger. And the photo you see at the top left is more recent photo of me. I work part-time at Texas A&M and part-time at a local research company called Knowledge-Based Systems. And my area of interest are data mining, analytics and machine learning, and natural language processing. I do lots of applications in crowdsource applications as well as biosurveillance. In terms of hobbies, I'm a very active poker player. So don't be surprised if you see me in World Series of Poker one of these days. Mm-hmm. I think poker is a combination of probability and psychology. I think I figured out the probability part of it, but I'm still trying to figure out the psychology part of it. By the way, I offer honors section of ISEN 310. So if that might be of interest to some of you. And I also offer undergraduate research hours, like Dr. Ferry was talking about. And I see that some of my students are here in the Zoom class today. In terms of some of the projects I'm working on, I do lots of applications on AI and machine learning based applications. One of the projects I'm working on is machine learning based prediction of aviation component demands. This particular project I'm working for US Navy as well as US Air Force. So the problem is they want to have a better prediction of the part demand for the aviation parts. In case your data is independent and identically distributed, you can develop models like theoretical distributions like gamma distribution or exponential distribution or Weibull distribution to model the part failure rate. And also in case you have seasonality and trends in the data, we can use standard time series techniques to model and predict demand for those parts. But what we observed in the case of aviation parts is there are other factors that influence the demand. For example, the environmental conditions, the number of times you land an aircraft, where you land the aircraft. Is it at the sea or is it at the land? So all these factors affect the lifetime of a part. So what we are trying to do in this project is to develop machine learning based models to understand how these features affect the lifetime of a part, and based on that can we predict the demand much better. So this is a project I'm doing for US Air Force as well as US Navy. Now this second project I'm working on currently is based on natural language processing, what I call semantic information extraction. This project I'm doing for Defense Threat Reduction Agency, DTRA. And the goal of the project is, as you can imagine, there are a lot of sensitive information researchers are doing in biological science. People are doing experiments like, can we make this virus more virulent? Can we increase the transmission of certain virus, of certain agents? So people are doing a lot of cutting edge research into these areas, and all for the good cause of science. But as you can imagine, some of these things can be misused. So the government is sensitive about the misuse potential of some of the sensitive research. They call this as a dual use research of concern. So the government wants to encourage this research, but they want to keep track of, okay, can we control the dissemination of this knowledge? So my goal in this project is to develop techniques to parse these scientific documents, extract the semantic information from those documents, extract what kind of experiments are they working on, what kind of experimental manipulations are they doing, are they increasing the virulence of these agents, are they increasing the transmissibility of these agents, what kind of entities are being involved in this relationship. And then based on that, can we identify that this document can be misused? So that's what we are trying to do in this project.
Oh, sorry.
Oh, I'm out. Okay.
Well, no, go ahead. I just wanted to make this. Go ahead, Dr. Aragunda, please.
Okay. Now, the third project I'm working on right now is what I call hyperglycemia prediction. This project is diabetes focused. Diabetes is a disease which results when the body is not able to produce enough insulin or not able to process insulin. And some of these diabetic patients used a device known as CGM, continuous glucose monitor. And what it does is basically it's a device you attach to your body. It monitors your blood glucose level, and you can know your blood glucose level in real time. So what we're trying to do in this project is based on this data about the continuous glucose monitor, can we predict what's going to happen 30 minutes from now or 1 hour from now? Are you at the risk of your glucose going too low, which is what is known as hypoglycemia, or it can go too high, which is known as hyperglycemia. And interestingly, hypoglycemia is a lot more important. It can lead to serious consequences. So we are focusing on how to predict hypoglycemia based on this kind of a data sets. And we have very good results. We have a patent pending based on this work. And also we are going to pilot this at Texas Children's Hospital in the next few months. Now, the last project I'm working on right now is, again, based on diabetes focused. I spoke about the continuous glucose monitor as a device. It's a very revolutionary device. But the problem with the device is it's a very intrusive probe. You need to insert the needle within your skin. So what we are trying to do in this project is, can we develop a non-intrusive suite of sensors that can give a good indication for your glucose levels? So we're going to explore a combination of ECG, which ECG sensor, oximetry sensor. Can we measure your sweat? Can we measure your temperature? And based on this wide range of sensory signals we have, can we estimate the blood glucose in real time without having to intrude into your body? So this is an NSF-funded project which just started. We are trying to see whether we can replace CGM by doing machine learning and advanced sensors system like this. So wide range of applications, mostly I focus on machine learning, NLP, and data mining for healthcare as well as in supply chain and logistics.
Thank you very much, Dr. Araguntla. All right. And sorry for cutting you off early on that. I'm going to do that for everybody. We've decided I'm just going to play that for everybody. But in any case, we can see Dr. Araguntla's email up at the top there. If you're able to stick around for a few minutes, Dr. M, then can be looking for chat-related questions also. But thanks very much for attending. Thank you for being here today. And let us see who are.
Thank you for the opportunity.
Yeah, excellent. Thank you. Okay, so now next up, do we have? There was a student. Is it Tapan? Is he present? For Dr.
Yes,
Bukapatnam? Yes.
Yes,
I would like to continue with him. So Dr. Zahabi has given us a video to play for her. She couldn't be here. So let's move ahead to try to be closer to the posted time here with your group, if you are ready. And if you have some slides to share, I'm not sure if we.
I do have. Yeah.
Great. Wonderful. Thank you very much.
Thank you. Yeah, I hope everyone can view the presentation.
Yes.
Yes.
And thank you. Perfect.
Okay. Good afternoon, everyone. My name is Tapan Ganatma, and I'm a second-year PhD student working under Dr. Satish Bukapatnam. And just to give a brief introduction about Dr. Satish Bukapatnam, he's the professor in our Industrial and Systems Engineering department. And he heads the Institute for Manufacturing Systems, the TIS Institute. And coming to the what our research group, we are like a team of 4 PhD students right now. The top, it's Bhaskar, so he's like the senior most PhD student whom we have, and then it's going to be me and Akash. And we have Yuha also, just like a new PhD student. And we have a couple of undergrad students also working with us. And our major work is focused on smart manufacturing. So as Professor Thomas has introduced, the 4 pillars of our industrial engineering department. So we are more focused in the manufacturing part. And within manufacturing, we are more into smart manufacturing. And this slide kind of captures what exactly goes on with smart manufacturing. So it's more like we have a lot of technologies that are into a confluence, and we try to use the pros of all these technologies to make a smart machine which would be helpful in various purposes, not only like in manufacturing very accurate parts, but also trying to like develop new materials and even see if we can like discover new materials from the existing ones. So our research domains are actually more concentrated towards these three. The first one being the autonomous material discovery and development, where we are focused with our smart hybrid manufacturing setup. So we'd like to take pride in our the machine that we have. It's an Optomic hybrid manufacturing system. So all of you must have heard about 3D printing and subtractive manufacturing, like a vertical mill also. So our hybrid system is like a mix of these both. So you can print and perform a subtractive manufacturing operation on the same machine. So that's why it's known as hybrid. And we are working on it to make it more smart in terms of like being able to manufacture any kind of a product. And right now we have like an ability to print titanium alloys, steel alloys, etc. And so we are working on making it more autonomous. And the next thing is manufacturing forensics and self-optimization. So this is something that has been of a major push in the industry, where people have been looking into how the real-time sensor data, etc., could be used to actually make better decisions while manufacturing a certain product. So all this is like tied up with artificial intelligence, machine learning, etc. All that the state of the art work. A lot of people are working on this right now. And the next comes cyber security assurance. So an integral part of Industry 4.0 was like, or rather any thing that's going on nowadays with any particular technological company, is the issue of security, cyber security. So manufacturing, you might think like what kind of information, like what would be the value of the information that could go out, but it's actually of huge immense value when compared to like the kind of products that we can actually generate. So that's what we are also looking into. And this is something like I'm completing this. So this is like some of my interests. So I'm into like this unsupervised segmentation of defects. So these are like some of the samples that we have from our setup. So we are looking into how we can identify this defects autonomously and see what can we do to actually overcome them. So that's how our team actually works. And you can visit our website, just SMTAMU, so you'll be able to like get more information on this.
Thank you so much, Tapan, and thanks to Dr. Bukkapatnam for having you give that presentation. That was wonderful. Thank you very much.
Thank you. Thanks a lot.
And any questions again can be entered in the chat, or can follow up with Tapan or Dr. Bukkapatnam. I am going to look for our next speaker. Here is Dr. Meyer. Rick Meyer, is he present? And if he isn't yet, then that's a great opportunity for us to show Dr. Zahabi. So, Dr. Meyer, if you
No, I'm here.
Oh, wonderful, wonderful. I'd like, if you're ready, we can do your presentation when you're ready.
Sure. Let me share my screen.
Wonderful. I'll stop sharing. Oh, I didn't. I never even did it. Okay, there you go. Thanks very much. All right.
So my name is Richard Meyer, and just to give you a little bit of introduction to me, I've got a bachelor's and master's in in math and physics and industrial engineering from Purdue. I came here in 1983 to pursue research. I mean, a PhD, and I got my PhD in 1988. Between my master's and coming back for the PhD, I worked as a systems engineer at the Air Force Integrated Computer Aided Manufacturing program there at Wright-Patterson. I joined the faculty in '88, and I was a tenured professor. I resigned my tenure in '97, but I currently work as an adjunct professor, principally because I am fully involved with a number of companies that I own, one of which is a research and development company called Knowledge-Based Systems. And I'm the remaining founder and also the president and CEO. My wife and I also run Spirit Ice Arena. If any of you guys have gone skating at the local skating rink, you'll probably find me in there most of the evenings. So the research areas that I work in are quite broad, but then again, I've been at it for a long time. So, you can collect research areas pretty much like guitars, if you'd like. I do a lot of work in planning, scheduling, so your classical industrial engineering ops research. Right now, the big push there is in using what we call 4D modeling of factories, where you use 3D models of the parts and the transport devices and the machining centers and other equipment, so that you can do dynamic scheduling and also interference predictions. So when you get into particularly our focus in my current research, there is in shipyards. So when you're trying to move a 200-ton block portion of a ship, there's a lot of planning that goes into that. I also do quite a bit of work, and matter of fact, the course that I teach in the IE department is in systems engineering methods and tools, IDEF modeling, DODAF modeling, UML modeling, and then the associated software engineering. When I was at Texas A&M full-time, I ran what was called the Knowledge-Based Systems Laboratory. My company's name is Knowledge-Based Systems. So obviously, I do quite a bit of work in AI, and that most of my focus today is in this area right here, quantum models of human cognition and decision making, and natural language processing and understanding. So the goal of the natural language processing and understanding is to actually be able to build models, if you will, micro world models from the processing of unstructured text or the result of interpreting speech. The goal of the quantum models of human cognition and decision making, what we're doing there is applying quantum probability theory to model how people form attitudes and how they make decisions, also how you can influence decisions. So that's very exciting. I also do work in cyber physical security, mostly in the attack path generation and analysis. So given that you have a configuration of a network and servers and switches and software, how can that IT infrastructure be attacked? And then how do you analyze to assess what level of risk you have against different attack vectors? Then I've also have some work going on in what's called intelligent adaptive scenario-based training. So it's training where you actually monitor the delivery of the course material to the student. You interpret his results, and then you you modify the training in real time to emphasize those portions of the content that he or she is not appropriately mastering. And then finally, healthcare. I'm sure you heard from Dr. Guntla. Dr. Grahl and Dr. Guntla and I work together quite a bit. But in the healthcare arena, we've worked in areas of blood management, disease prediction and forecasting. Gee, that's not an interesting topic right now. I wouldn't think so. How do you model and predict both the disease progression, which of course is always important, but the mitigation effects? So when you have a shelter-in-place order, does the policymaker making that policy decision know what the consequences are going to be on his constituents? And then finally, the ongoing. So we have research ongoing in that. We have a site, demic.kvsi.com, and you can. What we're trying to do there is put the COVID in the context of other diseases. So we've done flu tracking and flu forecasting for the CDC for years, and so, but there's not many people that remember that the 2017-2018 flu season, during that season, 45 million Americans got the flu, and it killed 80,000 of them. So, you know, putting a disease in context, you can understand, you know, how much mitigation is reasonable and what its effectiveness is likely to be. We also have some work going on in what's called Dirk Detection. That Madhav may have talked to this earlier, but basically that it's potential for misuse, detecting potentially misusable research results. So if I take a pathogen that's currently not airborne transmittable, and I do research to determine whether I can modify that pathogen so that it would be airborne transmittable, and it so happens the animal that I'm using to do my testing with is a ferret. Well, it turns out that a ferret lung is most similar to the human lung of any other species outside of another human. And so those results could potentially be weaponized. So the government would like to know and would like to limit the distribution of those results. So what do I do on a day-to-day basis? I consider it systems engineering. So I do a lot of consulting in the IE area on lean business operations, process streamlining. I oversee large-scale systems development for clients, and I do cyber risk management framework compliance. In the semantic technologies, as I mentioned, quite a bit of that is focused on surveillance, situation awareness, but there's also some that's in planning. So if you can monitor and understand the information that's being communicated by a set of text that's being transmitted, then you can predict the actions of a certain embedded group. The adaptive training right now is mostly being used. We've used it for both training manned and unmanned aircraft pilots. Right now we're training intelligence officers, and our next target is actually systems engineers, systems designers, to train people to design more robust cyber systems. I've talked a little bit about the disease forecasting and the risk assessment. The cyber area is principally in the cyber defense is a layered activity, and so we're focused on right now what's called PIT systems, which are embedded process IT systems, and also infrastructure protection. So electrical plants, water treatment plants on the infrastructure side, the B-52, the F-16, the A-10 aircraft on the PIT side.
Dr. Meyer, could I just interrupt quickly?
Sure.
I didn't tell you the timeline on this, so I wonder, we've got several more people stacking up, so I wonder if we could please
Sure.
wrap quickly. Thank you very much.
Sure. So, and finally, my research in the quantum probability is on, as we mentioned, the predictive models. I just threw a couple of slides in here. Principally, what I do is systems engineering. And people say, well, what is systems engineering? So the systems engineer role is to organize and manage cross-discipline efforts, and to identify, quantify, manage risks. But most importantly, a systems engineer provides critical thinking to a research team. As a matter of fact, there was a definition developed by a group at Texas A&M about 5 years ago. And this slide sort of summarizes the results of 7 or 8 different engineering departments that got together under the dean's insistence and came up with a definition of systems engineering that I believe is pretty much followed at A&M. So appreciate the opportunities, and I hope this was informative.
Thank you very much, Dr. Meyer. Yes, thank you, and really appreciate you coming in to introduce yourself and your work. That's excellent. So those who would like to follow up with Dr. Meyer with any questions, you can enter them in the chat now, or Dr. Meyer, your email address is, I forget right now, if you wouldn't mind. That.
You can email me directly at my company at rmayer.
The KBSI?
Yeah, rmayer at kbsi.com. Will come directly to me.
Wonderful. Thanks again. Thanks very much. I'm going to go to, oops, I shared the wrong screen, of course. Is Dr. Wolfe or Dr. Sagapuram here? We're gonna kind of call an audio and an audible, and if the faculty are here, we can go. Dr. Wolfe? Oh, wonderful. Did I hear Dr. Wolfe? She's technically first. All right, so let me share the correct screen so I can verify. Oh gosh, jeez, everything is the wrong screen. Okay, good. So we have videos from Dr. Zahabi, Dr. Nataimo. We're going to show them a little later because those are videos. They're not time constrained like a lot of the faculty are. So I will stop sharing now, and if Dr. Wolfe, either if you'd like us to share your slides, let us know, or you can
share.
Okay, go ahead.
All right. Howdy, I'm Dr. Sarah Wolfe. I'm an assistant professor. My email's right there. It's just wolfe@tamu.edu. It's Wolfe with 2 Fs. So I mostly teach the ISEN 281 course. It's kind of an intro to manufacturing course and an alternative to the MMET, I think 181. And typically this course is, in this course I talk about material properties and selecting materials, and there's typically a final project for the students where you can actually 3D print something and learn how to mill, learn about casting, and learn about different manufacturing processes. But with everything kind of online, it's more on the design side, but also like learning how to do manufacturing remotely. Some of my hobbies, I really love all kinds of food, and I love exploring food. I love cooking food and making a huge mess in the kitchen. I also play tennis, and lately I've been walking around campus just playing Pokemon Go. It's been pretty fun. And my research, so I'm in manufacturing, and I mostly look into additive manufacturing or 3D printing. And when you hear about additive manufacturing, that's more the technical term for 3D printing and what people use usually for 3D printing of metals. So for metals, you actually need to melt the metal, and metals have melting points of up to thousands of degrees in Celsius. So what I do is I take a lot of cameras and monitoring processes like X-rays, and I try to look at the melting of the metal process. So this figure right here is a snapshot of like a thermal video camera, a video of the thermal camera of the melting process. So you can see it gets up to like 2,600 degrees Celsius. And that's, I think in this case, it's like titanium melting. So I have a few undergrads taking this temperature data, and then we're trying to understand what's, how fast it's cooling, because it cools down really quickly, and how that relates to the final part. And for metals and sometimes ceramics, using additive manufacturing is really important when we're building prosthetics or parts for aerospace, because things have to be very strong and will also go through extreme environments or temperatures. And then these two images, this is an example of one of the X-ray images. So here I'm looking through the additive manufacturing process, and you can actually see the metal boiling. And then there's like melting, and you just see all these phases. And one of the things I'm interested in too is mixing and matching materials to create new materials. So in this case, there's like, I think this is tungsten, and I'm mixing it with a titanium, and these lighter particles are like a steel, and I'm trying to melt them together and make new metals. So I use a combination of a lot of imaging techniques and cameras. This figure here is basically where I do the X-ray experiments. It's the synchrotron, or it's kind of like a particle accelerator, and there are a few in the world. And so I go here from time to time, and I've collected a lot of data as well to come up with these X-ray images. But here in the lab on campus, I'll have a thermal camera as well as a high-speed imaging camera to look at that liquid phenomena. So it's pretty cool stuff. Thank you.
Very cool. Thank you so much. Yes. Thank you, Dr. Wolfe. Excellent. So here's my suggestion. So again, Dr. Wolfe, if you have a minute to watch the chat window, or again, her email address, wolff@tamu. And let me reshare, because here's what I want to do. Now, Dr. Sangahar, if you are ready, I would like to do, oh boy, wrong screen, of course. I want to alternate here, because the last few live speakers are, I don't want to have them too grouped. Why can't I ever figure out this stupid shared thing? Okay, there, that's better. So, Dr. Sangahar, I'd love for you to talk about your research now. Thank you very much for being here.
Absolutely. Thank you, Dr. Ferris. All right. Good afternoon, everyone. I'm going to be brief. Not a lot about me. I'm a dad of two. Not going to show the photos until you join my lab, so I keep that excitement for then. But they're pretty cute. One is 9-year-old. His name is Diaco. The other one is 3-year-old. My daughter, Diana. I love soccer. I played soccer in college. I coach soccer. I'm a licensed Massachusetts coach. And I watch a lot of soccer. So I don't know how much of it you like, but my claim to fame is my name is engraved on a piece of metal on right around the curbside of Juventus Stadium, which is the champions in the Italian league. I play guitars. I like heavy metal. So I play rhythm guitar, electric guitars, and I direct a lab called Applied Cognitive Ergonomics Lab. Some of you might know me as the instructor for ISEN 330 as well. I teach it alongside all the other faculty who teach it, but I think I'm going to teach it this coming spring. So if you're taking it, you're probably going to take it with me. Or maybe not, I don't know. We're still talking about that, so I'm not gonna make any promises. But what I did here is a collage of all the projects I work on. And this is probably not a good idea. So from the human factors perspective, this is kind of a what not to do. Cluttered displays and too much and, hard to read stuff. But I'm going to do it anyway because this is the poster I take to conferences to show my lab. And I think it's a nice representation of what we do. So my lab's work has 3 buckets. Bucket 1 is remote monitoring technologies. What do I mean by that? So it's lots of sensors and wearable technologies to detect something meaningful about people's health or performance. In particular, we have a big line of research on mental health. I'm very passionate about mental health research, and I'm looking for technologies to monitor and detect symptoms of mental health changes, and then close the loop, do something about it. And this passion started with veterans and PTSD, where we were losing so many veterans because there's no monitoring in between sessions. So we created a technology that sits on smartwatches that detects PTSD hyperarousals. And we can then, engage them in some sort of communication and start the therapy right away. That led into my other project on college student mental health, and that received the President's Excellence Award to look into college student mental health. And that you can relate to with lots of stress and anxiety you're getting from school, and especially a tough school like Texas A&M. I was really motivated to help. So we're working on a big technology to monitor students remotely and then give them some self-management capabilities as well, right on their watch, on their phone, so they can take care of themselves and their mental health. We also have a line of research on monitoring health and performance. So kind of taking the same mindset into industry and see if we can monitor people like nurses who are working in these safety critical domains that are life critical too. Remember, errors result in preventable deaths. So we're trying to monitor nurses' fatigue, burnout rates using these technologies, which are pretty non-intrusive. Just put a watch on the wrist, and we have some advanced machine learning and advanced analytics technologies to look into fatigue, burnout. We do detect hyperglycemic events, which is low blood sugar, using just looking at hand tremor, for example. We also have lots of oil and gas projects looking into things like safety culture, and if people are ready, do they have enough sleep to perform in an offshore rig, and monitor this remotely and in real time. The second bucket is healthcare systems engineering. I'm affiliated with Houston Methodist Hospital. I'm also a professor there. And I do a lot of healthcare systems. This is a lot of patient-centered design, kind of making sure things are designed for patients in mind and with patients' expectations and needs in various domains, ICU, surgical domain. I'm an expert in ICU and nursing, but the scope of the projects I'm taking on is much wider than that. This is a little bit of our lab, which has a usability testing facility in it. It's a one-way mirror, so you can see and watch and observe how users interact with technologies. This could be medical technologies or an app, whatever you're going to put in front of humans later. And you can analyze that rigorously and objectively later. I do a lot of telehealth and telemedicine nowadays, and my lab is playing a big role in a large NSF project called PATS Up, which is creating technology for underserved communities. And underserved communities don't get enough access to healthcare, so we need to enable them to do a little bit more self-management. So we need automated technologies. Telehealth provides a lot of promise there. This technology that you see in this photo is really cool. It's a 10-year project we started, and it's a sensor size of a rice grain that's injectable under the skin, under the wrist skin, and then all sorts of sensors and variables around it to read things related to diabetes or cardiovascular health, and then communicate that to other pieces or to the providers. So, if this technology happens, we can certainly have a lot more costs related to healthcare saved in the future, because people can take care of themselves with this concept of lab in the palm or lab in the pocket or lab on a wrist. The third bucket I'm really interested in is pure system safety and resilience engineering. So we look into emergency management, and we have state-of-the-art facilities at Texas A&M to look into emergencies and emergency management. Think about Harvey type of incidents. The way we respond to these is wide scale, lots of teamwork, lots of groups get together from different backgrounds. And I'm interested in understanding how to make decisions in teams, how team cognition is formed, what is resilience in that context, and how do you improve resilience to make those decisions a little bit quicker and save lives. And I have expertise in process control. So this is another part of our lab with lots of large screen displays and tabletop displays and touch screen stuff to test ideas to enable people who make life critical decisions in the military, in NASA command and control operations, in air traffic control, for example. So the really cool stuff to help the supervisors more than the operators, people who have to monitor everything in the back. So if you're interested in any of these, you can visit my website, our lab's website, acelab.tamu.edu, to learn more about the projects. And I'll be happy to answer any questions.
Thank you, Dr. Sasangahar. All right. So please, like before, if you have questions to put in the chat, that will be lovely. And we will otherwise transition. Thanks again to Dr. Sasangahar. Our next speaker will be Dr. Sagapuram. Do I share my, I need to just show this really quick. Sorry, one sec. So if you're late joining, what you see here, this is the remaining schedule. We've shifted things around a little bit. Dr. Sagapuram will be next. I've got a couple of videos, and then I figure I'll make myself last so I have the least amount of time. But then I will stop talking now. If you're just arriving, remember the event sign-in QR code here, and if you have questions there too. So turning it over to Dr. Sagapuram. Thanks very much. And you can share when you're ready.
Yeah, I'll go ahead and share my screen.
Yep.
Are you all able to see it?
Yes.
Okay, great. Hello, everyone. My name is Dinakar Sagapuram. So that's me on the left corner of the image. At least that's how I used to look before the COVID era started. That's the same me again on the right with my beautiful family. That's my wife and our 4 kids there. So I'm an assistant professor, having joined the department a couple of years ago now. I'm in the advanced manufacturing track. Typical courses I teach, ISEN 370, that's the production systems engineering. It's been a while since I taught it, but I would like to do so in the future sometime. And the another course I regularly teach is ISEN 281. That's the same course Dr. Sarah Wolfe was talking about. It's an introductory class to manufacturing, specially designed to introduce you guys to latest developments in manufacturing, aspects related to 3D modeling, CNC machining, 3D printing, casting, and so on and so forth. And also including electronics, programming, and how do we actually put all of these things together to automate things. And in a regular semester, a big component of the class is also a semester-long project where you get to develop a whole robot all from scratch by yourself. So I'm looking forward to actually going back to normal so that you can experience all of those things. Hopefully that happens soon. In terms of the research, we do several things. The prime focus is on understanding the physics of material behavior in manufacturing process. So when you think about it, how we manufacture things, we subject the materials to basically torture. We subject them to high forces, temperatures. So we are interested in understanding what happens to the materials, how do they deform, how do they fail, and what can we do about it. Another important area in our group is contact mechanics and friction. That is the mechanics of when 2 bodies come into contact, which often happens when you think about manufacturing of materials again. What are the issues there, and how do they influence process? In terms of the experiment, so we are primarily an experimental group. So we do develop a lot of in situ experimental methods, high-speed cameras and things like that. not only visualize the things in real time, what's happening to the material during the processing, but also to develop new materials with some interesting properties that we could not achieve before. Okay, so moving on to the next slide. So if you look at a couple of things in this slide, and if any of these things interest you, going from manufacturing to material science, metallurgy, or if you have taken high school physics classes or mechanics classes and then you liked it, and you are wondering how you can implement all of that in the industrial engineering context, or if you want to do some cool experiments like some of the things you are seeing here using high-speed cameras, where you can visualize things at a time scale of 1/1,000,000th of a second, or you are more engineering oriented, want to build robots, prototyping equipment, and so on and so forth, you feel free to reach out to me. So you have my email right there. It's very easy to remember. First name dinakar@tamu.edu. We have a lot of research opportunities available for undergraduate students over the summer as well as during the regular semesters. We have done that before. And also likewise, if you're interested in graduate school in any of these topics, feel free to talk to me. And by the way, just before I finish, all the images that you actually see here, they're all undergraduate projects. So just like yourself, you may actually find yourself in one of these images. Sorry if I did not take permission from you. So I thought it would be okay. All right, so I think that's all I had to share. And if you have any questions, feel free to reach out.
Thank you very much, Dr. Sagapuram. All right. So yes, we are getting close to the end here. Keep the questions coming in the chat. What I'd like to do next, let me just show this one more time. Okay, screen 2. And so where we're at here, this is again our schedule here. I just wanted to make sure everyone saw event sign in. Here are the things for the thing for questions. I also put it in the chat. I put the link for sign-ins for engineering honors in the chat. For the next 2 speakers, there are going to be video addresses, and maybe Yesenia, maybe let's do Dr. Nataimo first. No. Let's do Dr. Zahabi first and then Dr. Nataimo, so that she and I don't have too much overlap in what we talk about, Dr. Zahabi and I. So the next will be Dr. Nataimo, our department head for industrial and systems engineering.
I'm going.
Here.
Hi there, this is Dr. Louis Ntaimo. I'm so happy to talk to you today. I
Screen's not sharing yet.
So I can, be live, but unfortunately, I couldn't be there in person. I know we live now in a virtual world, but I'm here today to talk to you about my research. But more importantly, I just wanted to see and make sure that you actually enjoying listening to the great research that our faculty in this great department are doing. And so I'm going to share some of my research as well in the next few minutes. But before I do that, let me just tell you briefly about myself. I do work in the area of operations research and applications. I teach different courses in the department, and some of you have taken my 440, some of you are taking it now. But I do teach courses in facilities planning and material handling, systems thinking, nonlinear programming, stochastic programming, and so on. I'm working on 4 cool projects this semester, actually this year. One is in healthcare, the other one is on COVID-19. I couldn't help it, but I have to do something about COVID-19. And then I have a cool project on power systems and wildfire risk, and a big project on wildfire management. So I'll tell you more about those projects in a minute. But I wanted to also share my hobbies. I like to travel. I'm actually sad that because of COVID-19, I can't travel. Hopefully, we'll be able to travel soon. I love to play soccer. Again, I'm not playing soccer right now. I'm walking and running, and hopefully I'll start playing soon when things get better. So I love to interact with students, colleagues, as you can see in the photos here. But let me now tell you about my research. I know some of you are wondering, how can I participate in research? Well, I do need a couple undergrad students that can help do things on some of these projects. The first project is on healthcare. Here we are dealing with pathways modeling for community health. This involves, for a given county, the county provides health and social services, but the issue is they have limited resources. And how do you manage that, given that you have a lot of people needing, some people need help with health insurance, but at the same time, they may have health conditions that they need to take care of. So how do you schedule that? We're using stochastic programming to model that. A cool project I'm working on with Dr. Abrahamian, our own professor here, is on the counseling and psychological services at here at TAMU. They're struggling with managing students. How do you schedule students who are seeking psychological services or counseling? And so this is a cool project that my PhD student, Janio, is also helping me with. Another project is on COVID-19 research. Here we are thinking ahead, when the vaccine becomes available, who should be vaccinated? So we are trying to come up with with optimal vaccination allocation policies under uncertainty in the spread of the disease. Here we're using chance-constrained stochastic programming, collaborating with a colleague of mine, Krishna, and my two students, Janio and Brittany. We're collecting data and running models and so on. It is very exciting. Another cool project, if you love power systems, is related to the fires that were ignited a couple years ago in California. We remember the PG&E, the utility company there. Some of their power lines actually started some of these fires. And so we are dealing with the question of how do we minimize such things from happening? From the power systems point of view, we have to decide which power lines should be turned off when the risk is high. And so we have developed some cool models. We just had the paper accepted a couple of weeks ago, and so this is also exciting. And finally, I wanted to tell you about the big project. It's a 3-year project funded by the National Science Foundation. This one is dealing with fuel management. Fuels deal with the vegetation. Now, how do we manage the vegetation so that when fires happen, they are not extremely large? Now, to do this kind of work, we have to do optimization, of course, stochastic optimization. We're dealing with uncertainty in fire growth in vegetation. And also, of course, we have to do simulation models to be able to mimic, fire spreading in different vegetation. And also, I don't know about you, but I believe in climate change. We also have to take into account weather conditions, and also for long term, we have to also account for the changes in the climate, because that affects the scale of the fires that we are seeing right now in California. Anyway, so these are the 4 main projects that I wanted to share with you. The next, I think you're asking, how do I get involved in this research? What qualifications do I need to have? I just want students who like math, because most of it is based on math, but also having programming skills is key. So those are the 2 basic things that I'm looking for, okay? Now you have my email there, so feel free to send me an email if you're interested, and enjoy the rest of the talks by our great faculty that you're watching today. Thank you, and stay safe.
Thank you, Dr. Nataimo. Okay. Well, And thanks to all of you. If you have questions for Dr. Nataimo, I suggest you probably email to him at ntaimo@tamu.edu. And we are, of course, very happy and welcoming him as our new permanent department head. It's a great new year, despite it being 2020. We have a new department head and a new mission, a new energy all around that. So now for our second last presenter, could I ask Yesenia to please play Dr. Zahabi, and she will be next. And Dr. Zahabi also was unable to be here in person, but was gracious enough and wanted to, record a quick message for everybody.
I don't know if it was just me, but I felt like Dr. Ntaimo was here. He was the format.
Yeah. Yeah.
I agree with him.
Yes.
Okay, there's Dr. Zahabi coming up.
Hi, everybody. My name is Mariam Zahabi. I'm an assistant professor in ISEN department, and I'm also a director of Human System Interaction Laboratory. On undergraduate courses that I teach ISEN 210, which is Fundamentals of Industrial Engineering Design, and then I also teach ISEN 330, Human Systems Interaction. So what do I do? My research is mainly focused on investigating human-machine interaction in safety-critical system. And by safety-critical system, I mean I do research most of the time when people are under high mental workload, for example, driving. And especially for emergency responders, for police officers who are under high workload when they're performing their duties and they're driving at the same time. And I also do research in cognitive performance modeling. I do research in advancing these modeling techniques in order to quantify mental workload for people. And also I use these methods of modeling in order to theoretically assess cognitive workload or mental workload in different applications. So in this page, you see that, we have a very, very cool driving simulator in our lab that I have, a number of undergraduate students helping with me with the studies that we are currently doing. And then I also have 2 PhD students working with me on different projects. And you also see in one picture that we conducted, this was a study that we conducted last year, and my undergraduate student, he was doing ride-alongs with police officers and collect this naturalistic data from about 30 police officers. On the right top, you see my lab, which includes my PhD students and undergraduate students. And then we're also doing research with upper limb prosthetic devices, which is related to the cognitive performance modeling. So what I want to tell you is that if you're interested in doing research in human factors in my lab, so we currently have 3 funded projects. So the first project is on advanced driver assistance systems in police vehicles. So this study is a combination of field observation, surveys with police officers, and then next year we're doing a driving simulation research with police officers to see how advanced driver assistance systems can help drivers and police officers in order to reduce their mental workload and driving demands. The second project in the middle, this is just funded, and in this project I'm looking for undergraduate students as well. It's basically we're developing an indoor navigation system, an app for people with disabilities. Okay, so this is a system that we are hoping that can solve navigation issues for these population. So if you're interested in, for example, interface design, in usability evaluation, so anything related to, how we can better design interfaces, so this project might be a good fit for you. And then last but not least, we are working on another funded project by National Science Foundation, which we are looking at how can we measure cognitive workload of prosthetic devices. So this is a collaboration with Biomedical Engineering Department at NC State, and also computer science and industrial engineering departments in University of Florida. So basically we are assessing the mental workload of these upper limb prosthetic devices in order to help these amputee patients to select a device that better fits their individual differences and their needs. So all of these projects are really cool, and I currently actually have 3 undergraduates working me on different projects. And they're wonderful. So I highly recommend you to think about this. And if you are interested in doing research in my lab, you can contact me via email, which I provided right here. Okay, thank you so much.
Thank you, Dr. Zahabi. Woo! All right. Okay, we have reached the near end here, but there is one more least presenter, last and least, who is myself. Now, before I do that, let me just thank all of you for coming today. I appreciate it. I know the faculty appreciate your interest. Oh, I probably didn't share the right screen again. I just wanted to one more time show you my email address, because I'm going to show you here in a minute, but I would be a great contact point for more questions, more discussions on this. And I am going to put my email actually right in the chat window, so you'll super have it. Tamu, good. And by the way, this presentation has been recorded throughout, so we are going to parse the video and ultimately have clips ready to share with people. So if you email me, we may also be able to help that way. Okay, so here we go. Ready? 2 minutes. So I am Dr. Ferris. Hello. I'm an associate professor in the Health and Human Systems area. I'm also jointly appointed in TAMU Health Science Center in the Environmental and Occupational Health Department. And I, by my association there with the TAM HSC, I'm also the director of a NSF center, the Center for Health Organization Transformation. And while I don't have a whole bunch of examples of my healthcare related research in this presentation, know that this is always a big part of our annual research output. The courses that I teach, I'm a human factors engineer, human systems person. So here you see human systems interaction. I've taught 434, human error and system failures. That's Dr. Curry Gregg's. She's really taken that and really grown that class, but I have taught it. And then at the graduate level, I teach cognitive systems engineering, and right now I'm also teaching 635 human information processing. I'm generally interested in the research world of humans in interesting, challenging cognitive states. So I'll call those high stress, high workload, emotional loading, attentionally demanding tasks, multitasking. I'm kind of interested in the limits of what people can do cognitively. And I'm also interested in measuring that and relating it to performance. So you can see me with a bunch of physiological sensing systems, workload detecting sorts of measures there. Yeah, now personally, this is my lovely family, my wife Erin, my son, who is challenging all of you these days because he's much bigger than this, and I always have him take my exams and things to test for anything confusing. He usually does pretty well. And then my sweet daughter Hallie. I am a outdoors fan. I'm going to go outdoors this evening when we're done here. And disc golf is one of my major outdoor activities. My son and I, typically these days with COVID, we go a couple times a week. I'm also, I like fishing. This is me with my dad there, and I can't see my dad, but that's what I do with him. And I am a musician, so I got this going. Got my piano there, and I very much like to play music. I like to be creative in that realm. And I also like designing goofy electronic things, which I happen to have one here. So this is one of my light hats. And as you can see, I built this based on a little microcontroller Arduino. I've got an accelerometer on here, and I am relating the X, Y, and Z axes to the lights that come off. So I'll just wear this for the rest of my talk just for a little bit of clowning. But these are some more of my creations, my inventions that I do in my mad science lab in my backyard. Research-wise, again, as I mentioned, we are human sensing. We're detecting how well people can perform in different contexts, and especially interesting, cognitively interesting things like when I have high workload, when I'm doing the sorts of tasks, environments where they've got a lot of things going on. So aviation, we have a flight simulator in my lab. This isn't my lab, but we do work in that domain, in the driving domain. What you're seeing are a lot of advanced displays that we use, ambient displays here, haptics and tactile displays here. So if you are interested in displays and communicating in unique ways with people, by all means, let me know about that. We have simulations that need people who are interested in learning how these work and work, designing scenarios within them. And then we're always looking at physiological ways to get an indication of what's going on with people cognitively. So we have various sensing devices that can tell us, when heart rate changes, when it changes with a specific type of pattern, that tells us that people are working hard or not. And then finally, who am I looking for here? I want people that like this sort of goofy stuff, especially because I am wanting to be more and more gadgety. I want to be more and more oriented around building things, prototyping things to test them. So if you are interested in these things, which I know Dr. Sakapuram showed, a lot of you are going to get an opportunity to work with these Arduino sort of little tiny, microcontroller mini computers. But I also have done, lots of things in software and in wearable devices in particular. We are developing all kinds of ways to communicate with humans through those. And I think I'm getting played off. So I am all finished talking. Thank you very much for your time and attention today. Here is my email address right now. And by all means, I look forward to more conversations with any of you here, those who are interested. And thanks again for coming today. So if anybody has any follow-up questions, I'll hang around for a few minutes, but the event is finished. Thanks again. I'll put up the login slide one more time. And I will wish you all a wonderful weekend and rest of the semester if I don't see you otherwise. Thanks, everybody. All right.
I just want to, here we go. Okay, the studio, I love you, and Cameron Crowe, and Tom Cruise. I love you, brother.
Tom Cruise.
I love you, man. Derek Crowe, Sean Settles, Keith Butler, all my behind-the-scenes crew. Regina King, I love you. You did a great job when we made the movie. Everybody involved with the movie, I love you. Oh, my goodness. Here we are. I love you. I'm going to keep going. Harley Junior Agency, everybody.
All right, folks, unless there are more, we got some chat questions. Let's see if I can help. Oh, yes, thanks, Harrison. Nice to see you. I need to ask explicit permission from each of the faculty, and I'll probably need to sort of edit this video a little bit, but I will have it. I will also, I will let everybody know who attended. Well, let's see. I don't know if we know who attended, everybody. Well, you can let me know. I will have that video, but it'll probably be a week if that answers your question. Yeah. Ideally, we may post it on like the ISEN website or something. We're kind of working through that, all of those details.
We do have, Dr. Ferris, we do have an eCampus page for all our first students, so we can always post it on there.
That's a good idea. Perfect. Great. Thanks. All right. Any other questions from the crowd? Thank you all very much for being here. Yesenia and Abby, thanks very much too for your help. Very, very, very good to have your help.
All Yesenia. She gets all the credit. I just
That's true. Yeah. Yeah. Thanks, Yesenia.